Ever look at your phone and wonder what's really going on behind that glass? Today, we're skipping the slow intro and jumping straight into the everyday mystery that quietly runs almost every single app you use. Yep, we're talking about machine learning. You hear the term constantly, right? But how often do we actually stop to look at the mechanics? Well, by the end of this explainer, we're going to crystallize exactly how this engine works.
I mean, seriously, think about this for a second. How does Netflix somehow always know exactly what movie you'll probably want to watch on a Friday night? Or how does TikTok figure out the exact videos that are going to keep you scrolling for another hour? How does YouTube magically queue up the perfect next video? And how does your phone instantly unlock just by looking at your face? It's not magic, and it's not just random algorithmic guesswork. The secret behind every single one of these seamless experiences is machine learning.
I'm your guide today, and our goal in this explainer is to completely demystify this topic. We are not going to use confusing computer science jargon. And no, we definitely aren't talking about physical metal robots sitting at tiny desks trying to learn math. We're going to break this all down logically, so you can walk away with a crystal clear understanding of the tech that literally shapes your world.
Okay, let's peel back the first layer. Section 1, the machine learning magic. What actually is it?
Fundamentally, machine learning is a type of artificial intelligence. But here's the core concept. Instead of a human programmer typing out every single painstaking step a computer needs to take, machine learning lets computers learn patterns from data. Basically, it means teaching computers to learn from examples instead of strict instructions. Think of it kind of like teaching a child. If you want to teach a kid what a dog is, you don't sit them down with a biology textbook. You just point and say, "Dog," and you do it again. "Dog." Eventually, the kid's brain starts recognizing the patterns, right? The fur, 4 legs, a tail, barking. Then, one day they see a brand new dog they've never seen before, and they shout, "That's a dog!" Nobody programmed every little detail into the child's brain. They just learn from examples. And machine learning works the exact same way.
Moving right along, Section 2, strict rules versus examples. Let's dive into this comparison.
Back in the day with traditional programming, a human programmer had to write out these exact super rigid rules. For example, if you wanted an old computer to identify a cat, you'd have to write a strict rule that says something like, if the object has whiskers, and it says meow, and it is small in size, then it's a cat. It's incredibly strict. Machine learning, on the other hand, just takes that rulebook and throws it out the window. Instead of writing thousands of strict rules, you just feed the computer millions of examples. Like literally millions of pictures of cats. Eventually, it notices the patterns entirely on its own, and it gets shockingly good at recognizing cats without you ever having to explicitly explain what a whisker even is.
Now, you might be wondering, why did we even need to make this shift? Well, it's because real life is messy. Strict rules break super easily. Think about that traditional programming rule we just talked about. What happens if the lighting in the photo is really dark? What if the cat is incredibly fluffy and you can't even see the whiskers? Or what if the picture is just blurry? Traditional programming completely freezes up and gets it wrong. But machine learning, because it has studied millions of different examples under millions of different messy conditions, it adapts and still recognizes the pattern.
So, how does it actually pull this off? Let's look under the hood. Section 3, the 3-step process. It really all boils down to 3 steps. Step 1 is data. The computer gets fed lots of information: photos, videos, music preferences, text, numbers, the whole shebang. This is the fuel. Fun fact, models like GPT-4 were trained on roughly 45 gigabytes of text data alone. That's millions of books. Step 2 is training. This is where the computer actively studies the patterns in all that data. It starts asking mathematical questions like, what do all these faces actually have in common? Or, what type of videos do people actually finish watching? Finally, step 3, prediction. After learning the patterns, the computer makes a guess. You'll probably like this movie, or hey, this looks exactly like your face. That final prediction ability is the real magic here.
And honestly, this brilliantly illustrates just how prevalent this tech is. You're already interacting with those 3 steps every single day. When TikTok somehow reads your mind and fills your feed with cooking videos right after you watch a pasta recipe, that's just machine learning studying your watch time and your skips. When Netflix suggests a thriller because it learned your favorite genres. When YouTube recommends your next obsession. When Spotify builds that perfect weekly playlist. When your phone unlocks with your face. Or when Google Maps perfectly predicts a traffic jam miles before you hit it. It's all just data, training, and prediction. But hold on, this brings up a really fascinating question, and I want you to pause and consider this for a second. With all these incredibly accurate predictions happening constantly all around us, does machine learning actually think like we do? Are we talking about real sci-fi artificial intelligence here? Well, the short answer is no, not really. It is so absolutely crucial to understand that a machine learning model does not have emotions, it doesn't understand life, it's not sitting on a server farm somewhere pondering the meaning of its own existence. Instead, it's just extremely complex statistics and math doing pattern recognition. That's the key takeaway here. It simply finds incredibly intricate mathematical patterns in data that a human brain might just completely miss.
All right, let's keep the momentum going. Section 4. Types of machine learning. How exactly does it find these patterns?
Let's use some quick analogies here to keep this super simple. First up, supervised learning. This is basically learning with an answer key. You show the computer a picture and say dog, then you show another and say cat. You're literally giving it the labels until it learns the difference. Second is unsupervised learning. Here, there are no labels. The computer's just handed a massive pile of data and told to find the groups itself, kind of like analyzing millions of listeners to group similar music tastes together. And third, reinforcement learning. This is learning through rewards, very much like training a pet or playing a video game. The computer tries something. If it makes a good move, it gets a digital reward. Bad move, it tries again.
Let's zoom out to the macro level now. Section 5, the power and the flaws, the real-world impact.
The sheer scale of the power we're talking about here is staggering. Machine learning is a game changer because it handles a volume of information that would instantly overwhelm a human brain. I mean, doctors are using it to spot tiny anomalies in medical scans. Banks use it to instantly detect subtle patterns of fraud across millions of transactions. It powers the driving assistants in modern cars, and it's the engine behind tools that can instantly translate and understand human language. It is quietly running the infrastructure of the modern world.
But, and this is a big but, it is absolutely not perfect. The crucial point you have to remember is this equation: bad data equals bad results. Because machine learning learns entirely from the examples we feed it, if those examples are flawed or biased or incomplete, well, the computer's predictions will be too. Sure, this leads to bad movie recommendations, but it also leads to really dangerous face recognition errors, biased hiring algorithms, and incorrect medical predictions. It makes mistakes, which means human monitoring is still absolutely essential.
Almost at the finish line here. Section 6, AI versus machine learning. Let's clear up the confusion.
Here is the absolute easiest way to remember how these two connect. Artificial intelligence, or AI, is the big umbrella category. It represents anything designed to act smart or mimic human intelligence. Machine learning is just a smaller part of AI. It's one specific tool under that big umbrella that helps computers achieve that smartness by learning from data.
Seriously, if you take away absolutely nothing else from this explainer, I want you to remember this one concept. Machine learning is teaching computers to learn patterns from examples instead of following strict rules. It all just boils down to computers learning from data.
Man, look at how much ground we've covered today. You now know exactly what machine learning is, that three-step process of how it learns patterns from data, where you're interacting with it every single day on your phone, the massive power it holds for society, its flaws, and how it dramatically differs from old-school programming. You now possess the knowledge to confidently explain how your favorite apps actually work.
And that brings our journey to a close today. As these systems consume more and more data, the question isn't just what they're going to learn next, but how they'll ultimately reshape human decision-making altogether. The tech world is huge, and I love breaking it down for you. So it's your turn. What complex topic should we demystify in the next explainer? Should we dive into what an AI agent actually is? Should we map out cybersecurity? Or do you finally want to know how blockchain works behind the scenes? Drop a comment below, keep questioning everything, and I'll see you in the next explainer.
Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content like this. See you in the next one.
If you're curious how I create these videos, from AI voiceovers to video editing and research, you'll find my complete toolkit in the description.